Electric vehicles (EVs) are undergoing a revolution in terms of power delivery, and wireless charging technologies are providing an alternative that is both convenient and efficient to the conventional methods of plugging in. This video discusses 10 cutting-edge wireless charging technologies. These technologies are redefining the way electric vehicles (EVs) receive power, improving the user experience, and paving the way for a more sustainable future. Number 10. There are inductive charging systems. Who was the first person to develop an inductive charging apparatus for electric vehicles? To date, inductive charging has emerged as one of the most widely used wireless technologies for electric vehicles. The ground-positioned charging pad features a coil that produces an oscillating electromagnetic field. This allows it to function. Since the electromagnetic field induces a current in the vehicle's coil, when an electric vehicle that is equipped with a corresponding receiver coil parks over the pad, the battery is effectively charged without the need for physical connectors. The development of efficient inductive charging systems has been spearheaded by companies such as Redefining, which have achieved energy conversion efficiencies of more than 90%, which are comparable to those of conventional plug-in chargers. Number 9. The resonant magnetic coupling. Resonant magnetic coupling can make inductive charging more effective by letting energy flow over longer distances and giving the charger and receiver more options for how they are aligned. Even if the vehicle is not perfectly aligned with the charging pad, this method takes advantage of resonant circuits that have been tuned to the same frequency. This allows for efficient power transfer. According to research, resonant magnetic coupling can guarantee high levels of efficiency. This means that it could be useful for both fixed and dynamic charging situations. Number 8. Dynamic wireless charging. Who will test the A10 highway project for electric vehicle dynamic charging in France? The use of dynamic wireless charging (DWC) systems enables electric vehicles to charge while they are in motion, so decreasing the amount of time spent in idle and possibly increasing the driving range without the need for bigger batteries. The implementation of this technology involves embedding charging coils beneath the road surface. This creates a magnetic field that distributes energy to cars that are equipped with receiver coils as they travel over the existing infrastructure. Using inductive coils that are hidden under the asphalt of the A10 highway at Saint-Arnoux-en-Yvelines, for example, France is planning to conduct a test of a roadway that powers electric cars in the year 2025. By offering possibilities for continuous charging while on the road, this initiative intends to reduce the number of times that charging pauses are required and to reduce the size of the batteries. Number 7. Wireless capacitive charging. In order to transmit energy between conductive plates, capacitive wireless charging makes use of electric fields rather than magnetic fields. Despite its typical use for low-power applications, there have been developments to adapt capacitive charging for electric vehicles. This technology provides prospective advantages such as decreased electromagnetic interference and the capacity to operate through varied materials, yet hurdles remain in obtaining high power levels suited for vehicle charging. Number 6. Wireless charging infrastructure. Integration. Integrating wireless charging infrastructure into urban contexts is vital for wider adoption. We are planning innovative initiatives like developing an electric vehicle charging boulevard in Los Angeles, which we expect to finish before the 2028 Olympics. This project includes building underground charging stations that enable automobiles to charge while driving, removing the need for plug-in charging, and highlighting the possibilities for urban integration of wireless charging technology. Number 5. Solutions for high-power wireless charging. Who is most likely to benefit from the advancements in high-power wireless charging structures? In order to satisfy the requirements of larger vehicles and to shorten the amount of time required for charging, high-power wireless charging systems are currently being developed. Induct EV, for instance, has developed a system that is capable of sending high-power electricity to buses in a matter of seconds. Furthermore, each minute of charging can achieve an additional 3 miles of range. The reduction of downtime and the improvement of operational efficiency as a result of such improvements are especially helpful for public transportation systems. Number 4. Standardization and interoperability. It is possible to assure interoperability between various car types and charging infrastructures by establishing standards for wireless electric vehicle charging. In order to establish norms for wireless power transmission between infrastructure and cars, organizations like SAE International have been working on developing standards such as the J2954. When cars from different manufacturers are able to use the same charging infrastructure without any problems, standardization makes it easier for more people to embrace the technology. Number 3. Positioning systems for vehicles may improve the efficiency of charging. In order to achieve the best possible energy transfer, it is essential to position the vehicle accurately over the charging pads. The progress in advanced positioning systems, such as those that use machine learning algorithms like long short-term memory LSTM networks, has made it possible to control the alignment of vehicles in a dynamic way. In dynamic wireless charging scenarios, these systems are able to achieve a higher level of charging efficiency by predicting the optimal lateral position for maximum electromagnetic strength. Number 2, the incorporation of source energy that is renewable. Who are the most important players in the process of integrating electric vehicle charging systems with renewable energy? In order to create a more sustainable transportation ecosystem, it is beneficial to combine wireless charging systems with renewable energy sources such as solar or wind power. Electric vehicles (EVs) can have their overall carbon footprint reduced even further if renewable energy sources are incorporated into the grid that supplies infrastructure for wireless charging. This approach is in line with various global initiatives that aim to reduce emissions of greenhouse gases and promote the use of clean energy. Number 1. The focus is on the commercial deployment and market adoption of the product. Increasing numbers of businesses are beginning to implement wireless charging systems in their operations. There is a growing acceptance of electric vehicles in the market, as evidenced by the fact that companies such as ILO Technologies have secured orders for electric vehicle wireless charging systems in automatic parking lots. All of these new developments show that wireless charging options are both possible and appealing for use in the real world. This makes it possible for them to become widely used in many fields. In conclusion, wireless charging technologies are leading the way in transforming power delivery in electric vehicles. These innovations offer promising avenues for improving the convenience, efficiency, and sustainability of electric vehicles (EVs). These innovations range from inductive and resonant magnetic coupling systems to dynamic charging infrastructures and high-power solutions. The future of transportation will be driven toward greater electrification and environmental stewardship, and wireless charging is poised to become an integral component of the ecosystem of electric vehicles as research continues to advance and commercial applications continue to expand. Enjoyed the video? Don't forget to like, share, and subscribe to our channel for more exciting updates on wireless charging technologies and EV innovations. Stay tuned for more.